Hi and welcome to this part 4 on how to build a Sentinel robot in Gazebo Simulator using ROS Development Studio. So in this, if you remember, the first 3 parts were basically how to create a geometrical version of Sentinel robot. And now our objective is get as close as possible to this image, which of course we won't be able to do it exactly like this, but we'll try to have the meshes, we'll try to have claws, to have the eyes, and so on, okay? So the first thing is, well, we have to generate this mesh or get it in some way. Obviously, I'm not an expert in three-dimensional design, so I could do it in SolidWorks and so on, but this is more a 3D CG kind of skill. So the best way to find this stuff is normally to go to the pages of free downloadable 3D content. But I highly recommend you that in case of Gazebo simulations, because they are physical, they have to be physical, they have to be designed so that you are able to assemble them, because three-dimensional models, most of them that are made with 3D Max or Maya or whatever, they tend to be focused on being cool, like looking good, but they are not physically accurate. So they don't have joints, they do stuff that in 3 dimensions is okay, but in physical and simulation it's not very useful. So I found that the best place to find this kind of stuff is actually 3D printing websites. Because, as you can see, this model made by La Linea, oh, I don't know the name exactly, it's meant to be a physical breathing model. So all the parts that they give you here are meant to be assembled. So it's the best way, in my opinion, to get the model right. So what I did, what we are going to do is just download the files and work with this 3D toy model. Yeah. So once you have them downloaded, you can download them, no problem. So then I have already here the parts. So you'll get something like this. So a bunch of STLs with strange names, but it's really well made. It's classified by colors and materials basically, because it's meant to be 3D printed. So the first thing you have to do is classify it. So I've already classified it and I have all the versions here. So the next step you have to do is open Blender or your 3D model tool, but we are doing it in Blender. Okay, then let's get rid of this and let's import. So if you see all the files, let me just go, they are STLs, so they don't have color, let's say. So let's import it to see just what they are. So an STL, we go to our desktop, Sentinel models. Okay, and let's go to the originals. Let's see, for example, I don't know. Let's get one like this. The body, for example. It's a very good example. Okay, so we have the model here. As you can see, the scale, it's humongous. So if you go to metric, this is meters, so it's huge. So we'll have to fix this now, because of course you can use this kind of models with the scale and just rescale them down with Gazebo, but I found that it's better to have the proportions and the scale right from the start, and it makes life simpler. So as you can see, this is one of the elements of the body. So the first thing we have to do is get a sense of scale. But for that, I mean, how do we get a sense of scale of something that it's not real? So we need a reference. Here I got some references of images of the movie. So you can see we need some sense of reference, and one reference is the people. So you can see that the people here, more or less, the proportions is 1:1. So the Sentinels are more or less the same size of a person, let's say the body, and then the length of the tentacles, of course, is much bigger. But this one is very good because you can see exactly that more or less it's a human size proportion. So there's our reference. So we need now to, let me get rid of this. We need a reference, and this reference is people. So I need a model that I have already done with the correct proportions of a person. And gladly I have them because I've been working with person models before. I leave all these models, I leave them, I'll post them in the Git so you can download them, so no worries there. So let me go here. There you go, Bob. So I have Mr. Bob. Mr. Bob is a human model. As you can see, if each square is 1 meter, so the proportions are exact. So now I have a reference, okay? So then, now I can import my models and say, okay, I want to import, I don't know, the Sentinel front. As you can see, it's huge. It's huge. Okay, I've activated now the keyboard GUI that tells us what I'm pressing. So if we press N, then we're going to scale it more or less. Let's do, I don't know, let's do S. First of all, I have to select only this model, and then I'll scale it down, let's say to 0.01, and let's have a look. Yeah, so more or less I can see it has already a better scale. Then let's scale it again, 0.5. No, that's too much. Scale it 0.8. Maybe, yes, maybe. Let me move it around. Let me rotate it in X. Whoop, there we go. Okay, move it. So as you can see, it's more or less, you have to get the scale right. Then we go back again to our reference and say, okay, so it's more or less 2 times the body of a person. So, well, I don't know, let me check. 2 times the body of a person. Yeah, we could say that, yes, more or less. And there you go. This is the process of how to get the scales right. Okay, once you have them, so you just memorize the scaling, and then we can get the person. The best way, I suppose, is just to redo the process again. So just do a new one, remove all this junk, then import STL. Let's go web. Let's go here. sorry, for example, the front. Now I have it here, so I'll scale it 0.01, enter, and then, oh, I forgot, so let me redo it again. So one of the most basic things that you have to do when you work is get the units right in Blender, so that when you import, there's nothing wrong, there's nothing strange happening with the units. So let's do it again. So we have it here, we scale it down 0.01, then we scale it again, scale it 0.7, yeah, that's a good scale. Okay, then we can put the origin in the right place. So let me put this right. So GZ, there we go. Then we do object transform origin to the 3D cursor so that we have it here. Then I rotate it in X 90 degrees. There we go. So now we have it around here. Then if we want, normally what we want is the X axis to be to the front. So I'm going to rotate in Z 90 degrees. And there you have it. Now we can move here and GZ, move it, for example, put the origin just there. I don't know. This depends on you, on where you want to put the origin of each piece. But always remember to do this, origin to 3D cursor, and then you have it. And now you can just export it as STL, and you export with the name and so on. And you do it for each piece of the robot. So, because I don't want to do a video of like 20 minutes of mesh working. So once you have all the pieces together, you have them all rescaled and so on. The best thing now is, okay, now let's put it in Gazebo. So let's go to our simulation. So I'm using ROS Development Studio, which is a platform, web-based platform for ROS development. And I've already launched my simulation, well, my environment. And let's go to the IDE. I have already my code here prepared. You've seen this already in the other videos, so it's nothing new here. So here, what I've done new is I've created this meshes folder, and inside it, it's very important that you classify meshes, otherwise it would be a mess. And I've classified in body parts and tentacles, basically. So in the body parts, for example, I have the torso, which what I did, and this I can show you here, is instead of doing this, doing it piece by piece, what I discovered is that if you import the models, because the export was done from an original model which had all the torso complete, let me show you, because there are 3 body parts. These were divided because when you 3D print, you can't print them together. So if you imported everything, they have the origins exactly in the right position. So what I did now is export this as a whole, because for us, it doesn't make any sense to have 3 parts of the torso, because in the geometric model, we only have 1 part. Yeah. So there you have it. So we go back. So that's what I did. That's why we have only one torso STL. Then we have the arms, we have the eyes, everything. Okay. Okay. So how do we add these meshes? So let's, if you remember, the basic URDF that we're using is this one. So we use this common properties URDF chakra, and we use this body URDF, and then all the tentacles that we have, in this case 17. Yeah, why? Because if you go here in this model has 17 tentacles, plugs, you see? Okay, so we have to build them. Okay, so we have this. Let's go to the body because it's much easier. Body is exactly the same as we did in the geometric, just that we are replacing the cylinder by this mesh, which is Sentinel description package. Okay, here, and then meshes, body parts, torso STL. That's it. And another thing that it's different, you see that the origin, it's in the 0, 0. Why? Well, because you have to be intelligent, and when you prepare your meshes, it's much more effective that you place the origin exactly where you want it to. Okay, we just do this displacement because the origin in cylinders is in the center and we want it on the back. But here in the models, you can do and put it anywhere you want. So use that in your advantage. That's why there's nothing here. Okay, and that's it. You have the body already. Okay, now the tricky part. Now the tricky part. So the tricky part is obviously the tentacles, which, let's have a look to the original. So you can see in these images that it has two pieces. It has this rings, black rings, and this red rings. These red elements are the ones that connect them, and then we have these black rings, okay, that are like the pretty parts. So in our case, what we are going to do based on the model that we did is we are only going to put the black rings first. And then in probably the next tutorial, we'll try to put this connection because it obliges us to add more elements that we had in the geometric model. But to make it simple, we are just sticking to adding the meshes. Okay, so we have this tentacle macro that you already know. We have, so for example, we have the auxiliaries. Here we've placed the cylinder, which you remember was like the joint. And as you can see here, we are leaving it in cylinder. Why? Because this will be invisible, practically invisible. Because the only thing that we want to see is this black rings, okay? Then to make it invisible, one of the things that we could do is just not put visuals, but the other one, which is the one I prefer, because it gives less problems and so on, is just make them really, really tiny. So all the dimensions, as you can see, are really, really small. Okay, so we have this auxiliary, then we have this, the base one, which we are converting this origin to this Sentinel shackle gray STL, which is this black ring here. Yeah, this black rings. Okay, then we have this is exactly the same, apart from one thing, which is you see the origins here. So the connection between the auxiliary and the base, you see that now we're not displacing it. That's because we want to be in the same spot, because these joints are spherical, so we want it to be exactly in the same place. Yeah, just to look better, more realistic. Okay, that's it for the tentacles. So basically it's changing the connections of the joints a bit so that they are closer together, and then putting the mesh, and then in the base, so this, if you remember, this element was the one that connects directly to here, to the torso. So here we added a pitch and a roll to make it move better, because otherwise it would be linked to the base directly, which is not very good because you don't have roll and pitch. And essentially what we're doing here is connecting this first roll to the body, and then we have this pitch that is connected to the roll here with an axis of pitch, and then we have connected the let's say the base with the mesh with a fixed joint. Okay, perfect. Now we have the meshes. And that's it. Well, there's one thing which it gives problems, which is okay. In the original model, in the geometric model, the torso was a cylinder. So attaching each tentacle to the torso was very simple, and we did it with an algorithm, and we did it so that we placed all the tentacles in a circle. But let's have a look here. Here, each tentacle is placed in a specific place, and it's not a geometric shape that we can generate the positions. So we have to put each one of them in the correct place. So what are we doing? We are creating this tentacle pose that will be replaced when we generate all these tentacle 1, tentacle 2, 3, 4, 5 with the correct value. And this we have to do it outside chakras, because chakras doesn't allow us to do this easily. So if we go to our generate tentacle chakras, you see that now we have this tentacle pose array and E, which are the positions of each of the tentacles. So this one is the X and X of the first tentacle, and so on, of the 17 tentacles. And then when we generate all these tentacle 5, 6, 7, we then replace these. This tag, so tentacle pose X and Y. If it goes here, we say, okay, replace these tags with these values, which are from this array. Okay? Yeah. So if we go here, for example, you see that they were replaced by 0, 0, 0 in here, then it's another value, and so on. Yeah. Okay. So basically that's it. That's it. So let's have a look how it performs. As always, this, when you try it, you have to do it by trial and error. So you try it, you see that it's a bit displaced, then you move it, and so on. It's the only way, really, if you don't have the original model with SolidWorks. Sorry. So we go to spawn Sentinel, we say, okay, we want, in this case, I don't want to break my computer, so I'm just going to put the 17 tentacles, but only with 2 elements to make it simple. Otherwise, it's 17 tentacles. If we put as many elements as the real model, it's like 20 elements maybe. So 20 by 17, it's too much for my computer to deal with it. So let's dig in. So the first thing is I'm going to launch the simulation. Let's go here and do the main, which is an empty world. Okay, while it loads, we are going to our Sentinel scripts. You remember that we use this spawn, which does a load of stuff. So what it does is generate all the control files, generate all the tentacles, chakras, substitutions, and so on. And then it spawns and initializes all the controllers. So we have it, sorry, yeah, I think we have it. So let's go. There we go. There you go. So now we have the 17 tentacles attached in their places with the controllers. So one of the things that I had to do also, so some modifications so that this doesn't go very crazy, is I had to deactivate the self-collisions of the tentacles, otherwise these two elements would collide, auto-collide, so it wouldn't look pretty. And also one of the things I had to modify is the weight of the torso, because in the originals we had more or less the same mass of the torso as each of one of these elements. So when these elements moved, it moved the torso around really fast, which is not very realistic really. So because we're floating in space, if we move a mass around, then it will move all the elements. So in this case, I made this model, the body. Let's go to the common. So you see the body mass of is 1,000 kilograms, so 1 ton. And then the tentacles, it's only 1 kilo. So basically, if we moved all the tentacles, we would probably move the robot around. Okay, and then just to test, just to have fun, let's move around. So as you can see, we have the model without the colors. So this will be the next video, probably, which will be adding colors and adding all the lights and all the arms, little arms that we have here, and the claws to the tentacles. So don't worry. Okay, let's do ROS CD Sentinel, yeah, scripts. Then I'm going to do a Python move Sentinel, 17 tentacles with 2 elements. There we go. And now we start to move it. Yeah, as you can see, we have a load of work to do, but we're moving it just now. So this is just the physics going crazy. But there you have it. So now we have the meshes here imported. And now next video, we will talk about how to make this don't go crazy, add some colors and maybe some locomotion. Yeah. So thank you very much. We leave it here for today. Please consider subscribing to our channel. We publish every day ROS related content. We would love to see your own crazy robotics projects. So post videos, GIFs or whatever you want in the comments below. Have fun with robots and see you in the next video. Bye.